Hello, I'm Andrew, and this is my lab report. So, the purpose of this lab was to look at the effects of Newton's second law and the momentum principle on an object moving at a constant velocity. And so, explain the main principles. So, the second law is the net force is the mass times the acceleration, and momentum principle is p, which is momentum, is the mass times the velocity, and change in momentum indicates that the system has interacted with something. And so for my object, I chose a car that I took a video of moving outside my window, and the surroundings were the road, air, and everything that's not the car. And so some assumptions that I made was the car was moving at a constant velocity. There's zero net force on the system, and the mass of the car is constant throughout. And here's a video that I took. It's pretty short, but the car's moving at a pretty constant velocity. And then I used Tracker, and they produced a model for the car's motion, and it's pretty linear, so it means the car was moving at a pretty constant velocity. And so then I went to GlowScript, and I kind of modified the Python code where over here I made the velocity constant. Initial time is 0.25 because that's what the tracker model said. Delta t is 0.05 because each step in tracker was 0.05 seconds. Net force is 0, and then every time in the while loop the position would get incremented by velocity. And this was the plot that GlowScript produced, and that's for that. The previous one was for the position versus time, and this is for velocity versus time. And they were pretty. This is pretty similar, really similar to the one produced by Tracker. So, extrapolating the position was pretty accurate. And so to answer the what if question, so what if the x-axis was flipped? Then the velocity would be negative because the direction would be negative, and the momentum as a result would also be negative, and the net force would still be 0. And what does it mean? So we can kind of count the amounts of pushes and pulls to achieve a net force of 0. So the engine produces a forward force, or a force in the positive direction, and the friction produced by the tires and the road, as well as the air resistance, will neutralize that in the opposite direction, and that will create a net force of 0. And then also the weight and the normal force, they'll also be neutralized. And to conclude, since the two position versus time graphs were pretty similar, then the net force is pretty close to 0, because we already assumed the mass of the car to stay the same, and the velocity is approximately the same, so momentum stays close to what it was. And as I said earlier, because there's no change in momentum, then there's no interaction, which means there's little to no net force over the time period. So yeah, that's my report.